echelon form. U and reduced row form and reduced row form R. We'll also talk more about the solution of Ax equal to B, and I think we're going to do a couple of examples just to clarify how do we find the pivot variables and the free variables and so on and so forth. So okay, let's start with this example. So A is a 3x4 matrix. 1, 2, minus 1, 3, 6, minus 3, 3, 9, 3, 2, 7, 4. This is column 1, this is A1, A2, and we can see A2 is 3 times A1. This is A3, and this is A4. And A4 is, if you subtract A1 from A3, you'll get this one. So A3 minus A1. So actually we have only 2 independent columns, this one and this one. So we want to see whether do we have 2 pivots here or not, how many free variables are there, and what is the solution if we have some different, we have B's which are different than 0. So let's do row operations. So I want to do minus 2 row 1 plus row 2, minus 2 row 1 plus row 2, and then I want to add row 1 and row 3, row 1 plus row 3. So I'm going to get 1, 3, 3 as is. Minus 2 plus 2 is 0. Minus 6 plus 6 is 0. Minus 6 plus 9 is 3. Minus 4 plus 7 is 3. 1 minus 1 is 0. 3 minus 3 is 0. 3 plus 3 is 6. 2 plus 4 is 6. And if I do minus 2 times row 2, if I do minus 2 times row 2 plus row 3, I will get 1, 3, 3, 2, and then I'll get 0, 0, 3, 3, and 0, 0, 0, 0. So this is a pivot, this is a pivot, and what are pivots? This is pivot, and this is also a pivot. And this is kind of an upper triangular matrix, so this is EU. Because if this is the main diagonal, everything above the main diagonal is non-zero, everything below the main diagonal is 0. Okay, so we say, and this A is 3, this is number of equations, and this 4 is number of unknowns, So the number of columns is actually the number of unknown, number of rows is the number of equations. So number of equation is the number of rows, and number of unknowns is the number of columns. Okay. So what is the pivot? Pivot is the first. So pivot is the first non-zero entry in the row, non-zero entry in a row, and below each pivot there is a column of zeros. Below each pivot there is a column of zeros. Below each pivot there is a column of zeros. So this is a column of zeros. Okay. And each pivot lies to the right of the one above it. So which gives this the staircase pattern. So each pivot lies to the right of the pivot in the above row, and this produces the staircase pattern. This implies a staircase pattern, which we are calling as upper triangular matrix. And what is the corresponding L, by the way, from chapter 1? What is the corresponding L? So corresponding lower triangular matrix, corresponding lower triangular matrix, L is, so if you recall, L is the negative of this one, negative of this one, and negative of this one. So L is equal to, so first we did minus, so it's a low triangular matrix, so 1, 1, 1, because L times, so U is 3 by 4, so L has to be 3, L has to be, it's 3 by 4, so L has to be 4 by 3. L has to be 3 by 3, I'm sorry. L has to be 3 by 3, so that this 3 cancels with 3, 3. So 3 by 3 means it's a low triangle matrix, so elements above the main diagonal are 0. So this is minus 2 row 1, so this will become plus 2. This is minus row 1 row 3, so this is plus 1, so this is minus row 1 row. This is minus 2 row 2 and row 3, so this is plus 2 and row 2 and row 3. And you can, I encourage you to go home, so compute L times U, and this should be equal to A. Okay. So in general, however, when there is a row exchange required, in general, P times A equals L times U, where P is the permutation matrix. So this is, in general, this is true, but here we do not require a row exchange, so this is all right. Where there A is M by N, this is M by M, and this is M by N, right? And this is also M by N. This is also M by M. So we have an M by N by N, M by N matrix over here. Okay. And how do we get R from U? To get R from U, all you need to do is, this implies every element above and below the pivot, every element above and below the pivot is zero, and also normalize the pivot to 1. Normalize the pivot to 1. This is just to so that it's simplified when we are finding the variables. Otherwise, we have to divide by the pivot. So U is, so our U was 1, 3, 3, 2, 0, 0, 3, 3, 0, 0, 0, 0. So I will normalize it first. I can do normalization before or after, doesn't make a difference. So maybe I do R2 by 3 first. Or maybe I don't do R2 by 3 first. I simply do minus row 2 plus row 1. If I do that, this is 1, 3. This is 0, 0, 3, 3. This is 0, 0, 0, 0. So this is a pivot. This is a pivot. So minus 3 plus 3, this becomes a 0. Minus 3 plus 2, this becomes a 1. And then what I do is I do R2 by 3, which when I do that, this simply becomes a 1, this becomes a 1. So this is a pivot. This is a pivot. So then I have pivot variables and I have free variables. So this is called the reduced row echelon form. This is R. This is R. Everything above and below a pivot is 0. Everything above and below a pivot is 0. This is U. So this is the reduced row echelon form. Reduced row echelon form. This is also all right. All we need to do is, if I solve this one, so this is, if x is u, v, w, y, this is 3. So let me say right here. So if you want to look at this variable, so if x is u, v, w, y, this equation means, so this implies u plus 3v plus 3w plus 2y equals some constant, maybe 0. And then we say 3w plus 3y equals some 0. This equation over here simply states, and by the way, this equation is simply w plus y is equal to 0, and which is this equation. So this equation here is w plus y equals 0, and this one is u plus 3v plus 0w minus y equals 0. So this one and this one, this is much easier to manipulate if we know, okay, the coefficients are 1. That is what the difference is between the reduced row and between the echelon form and the reduced row echelon form, where we simply make everything above and below the elements of the pivots equal to 0. And note that for a square matrix, for a square non-singular matrix, for a square non-singular matrix, R is simply the identity matrix. Also from R, and we are going to do right now, also from R we can find the null space of A, because Rx equals 0 has same solution as Ux equals 0 and Ax equals 0. Okay, so let's see how do we figure out what are the pivot variables and the free variables. Actually, we have already done this before, so it's just a reiteration of what we did in the last lecture. So R times X equals 1, 3, 3, 2. Sorry, I'm sorry. 1, 3, 1, 3, 0 and minus 1. 1, 3, 0 and minus 1. This is 0, 0, 1, 1, and this is 0, 0, 0, 0. And this is u, v, w, y, and this is equal to 0 over here. So this is a pivot, the first non-zero element. This variable unknown corresponds to the first column, because if you recall Ax, this variable multiplies the first column. This variable multiplies the second column. So these are pivot variables. Maybe I make them square. Let me make them square so that we know that these are pivot variables. So these are pivot variables, u and w. So pivot variables. Why? Because correspond to columns with pivots. And the others, maybe I've circled them. These are free variables. They can take on any value. These are the free variables and can take on any value. So assign arbitrary value. to free variables. And obviously, so if we can assign arbitrary value to free variables, so this implies pivot variables are determined in terms of free variables. So let's see, and then I'm going to tell you how to write directly. So Rx equals 0 implies u, the first equation here, u plus 3v minus y equals 0. Second equation implies w plus y equals 0. So this implies, so which are the free variables? The free variables are v and y. So I'll write this one as u equals minus 3v plus y, and this implies w equals minus y. Okay, if I do that, but what is x? And I also know v equals v and y equals y, and y equals y. Obviously, v is going to be equal to v and y is equal to y. So this implies x equals u v w y equals, so this is v and this is y. So we have free variable here u, and I have free variable here y. So u is equal to minus 3v, I'm sorry, this is v. U is equal to minus 3v plus y. V is equal to v is equal to v. W is equal to minus y. So w is equal to minus y, and y is equal to y. Right? Okay. So what we have done is, this is a free variable, this is a free variable, this is a free variable, and this is a free variable. So what we have done is, we have alternately assigned 1 and 0 to the free variables, 1 and 0 to the free variables. And this 3, so if you look at the non-zero portion, maybe I have the black one, the red one here. Okay. Look at these values. So this 3 and this 3 is on the left of the equal to sign. So when this 3 goes on the right of the equal to sign, because this is u, this becomes a minus. So this is this 3, and this 0 is actually this 0 over here, right? And this one becomes a plus 1 here, and this 1, when this goes on the right side of the equal to sign, will become a minus 1 over here. Right? So this is how, directly from the reduced row echelon form, you can write. So everything that is on the left of the equal to sign, when this goes, this becomes a negative in the solution, and your free variables alternately take the values 1 and 0. This is how you write the solution directly from the reduced row echelon form. So let me write free variables alternately alternately take on value 1 and 0, and all solutions are actually so all solutions of x, so all solution of x are linear multiple of these two vectors, So these two vectors are actually generating. So this implies, so these two vectors are generating. So this is an important thing. Are generating the null space. They are generating the null space of A. Why? Because these x is the solution of x is the solution x is the solution of Ax equals 0. Right? So obviously we're going to get the solution of these. We are going to get this. So the solution of this Ax equals 0 generates the null space. So if a matrix has, more columns, which means more unknowns, more columns, that is n, than the rows, which is m. This implies n is greater than m. Maybe I also introduce one more thing here. The number of pivots, number of pivots equals the number of non-zero rows, is the number of non-zero rows, and this, by the way, is called maybe I say the number of pivots equals the number of independent columns. Maybe I write this. Maybe I write this. So number of pivots equals number of independent columns, which is the same as number of independent rows, which is the same as number of non-zero rows, which is the same as the rank of a matrix. This is called, by the way, R. So R is the number of pivot variables, if you just want to see that. So if a matrix has more columns n than the number of rows m, then since this implies since m is less than n, since m is less than n, this implies, since m is less than m, this implies there are at most m pivots. There are at most m pivots or m pivot variables or n minus m free variables. And whenever we have at least one free variable, we'll have this solution, and this is a line. When we have more than one free variables, we have a plane generated by these two vectors, and if we have more than two, then obviously we have high dimensional planes or high dimensional subspaces, null spaces that we can generate with these two vectors. Okay, so since m is less than n, there are at most m pivots or m pivot variables or n minus m free variables. There will be more free variables there will be more free variables. Obviously, if no more free variables, there will be more free variables if if some rows of R reduced to zero, and which that is the case over here. Here m is equal to 3. Here m is equal to 3. M is equal to, so m is equal to 3 and n is equal to 4. But there is this one row which is 0. So your number of pivot variables is 2, and the number of non-pivot variables or the free variables is 4 minus 2, which is also 2. Okay. So there will be more free variables. Some rows of R reduced to 0, and AX, or maybe or at least, so in any case, however, at least one variable must be free. One variable must be free, which means we have a line of solutions. This implies AX equal to 0. So if AX is equal to 0 is such that m is less than n, which is the case here, which means we have a fat matrix. So if this is a fat matrix, we have a fat matrix. So if AX is equal to 0 is such that m is equal to less than n, then there are more solutions. There are more solutions than x is equal to 0. Why? Because of free variables. So whenever you have free variables, you will have infinitely many solutions. That's the simple case. So there are infinitely many solutions. So there are infinitely many solutions. There are infinitely many solutions since any multiple of x, that is c times x also satisfies a times c times x equals 0, which implies null space of A contains a line through X. And this is where we stopped in the last lecture, when we drew that line with a negative slope that passes through 0. And if there are additional free variables, which is the case in this example, if there are additional free variables, then the null space becomes more than just a line in n-dimensional space, So to recap, dimension of null space. So dimension of null space, actually you don't have any idea what I'm writing, what is dimension, but dimension of null space is equal to the number of free variables, and the dimension of column space equals number of pivot variables. pivot variables. Why? Because the number of pivot variables tells you the number of independent columns, and the number of independent columns tells you generate the column space. So what is dimension? So you need to wait until the next lecture. So dimension is simply a number. It's a number. What number? It's the number of independent vectors. It's the number of independent vectors that generate the space, and this number cannot be increased or decreased. So this dimension and dimension of a subspace is not unique. So the number of independent vectors is fixed, but there can be multiple number of independent vectors that generate the space, same space. So maybe it's not recapping, this is going ahead. Okay, so let's do an example. We want to solve what happens when b is not equal to 0. So what happens? So this is all when b is equal to 0. So we want to solve ax equals b or ux equals c or rx equals b. B where b is not equal to 0. So let's see what happens here. So let me write an example. Same matrix 1 3 3 2 2 6 9 7 -1 -3 3 4 u v w y equals, so this is 3 by 4, this is 4 by 1, so obviously this is 3 by 1, b1 b2 b3. So this is b, this is x, and this is ra. So we want to solve ax equals b. Again, I'll do some row echelon form, but I'll have this b1 b2 on this side. So I'll do, let me write the first equation, 1 3 3 2. This line specifies this is actually the equal to sign, okay, and this is b1 over here. So whatever I do on the left side, I obviously do on the right side so that the equality is maintained. So we say -2 row 1 plus row 2, and I'd say I don't say minus, I just say row 1 plus row 3. So -2 plus 2 is 0, -6 plus 6 is 0, -6 plus 9 is 3, -4 plus 7 is 3, and this is b2 minus 2b1, right? Okay, 1 minus 1 is 0, 3 minus 3 is 0, 3 plus 3 is 6, 2 plus 4 is 6, and this is b1 plus b3, b1 plus b3. So now I want to get rid of these 6's, so I say minus row 2 plus row 3. So this is 1 3 3 2, nothing changes here. This is still b1. This is 0 0 3 3, nothing changes here. 0 0, I'm sorry, this is not minus r2, this is minus 2r2. Minus 2r2 plus r3. So -6 plus 6 minus 6 plus 6, 0 0. This is still b2 minus 2b1, and this is b1 plus b3, b1 plus b3, and minus 2r2. So minus 2b2 plus 4b1 plus 4b1, and this is equal to 4b1 5b1 plus b3 and minus 2b2. Maybe I write it again over here. So this is my u. So this is my u, and this is my c, right? Ux is equal to c. Okay. So let me write it over here. So ux equals c implies, let me write it, 1 3 3 2 b1 b2 minus 2b1. This is 0 0 3 3 0, 0, 0, 0, and this is B3 minus 2B2 plus 5B1. So this is C, this is U. Now this line is still Ux is equal to C. So this system of equations, so Ax equals B is inconsistent unless this side is equal, because this is 0, x is equal to 0. Unless this thing is 0, this won't have a solution. So unless B3 minus 2B2 plus 5B1 equals 0. Because this will be 0 times x equals 0. So unless this side is 0, this is 0, this will not have a solution. Okay. So even though there are more unknowns than equations, a solution may not exist. So we will not have a solution. The solution is for Ax is equal to B. For Ax is equal to B, the solution is not guaranteed unless and is not guaranteed even if the number of unknowns is greater than the number of equations, which was not the case for Ax is equal to 0. So Ax is equal to 0. If the number of unknowns is greater than the number of equations, we will always have a solution. We have infinitely many solutions at least because of the free variables. But unlike Ax is equal to 0, in Ax is equal to B, we will not have a solution. We may not have a solution, and we may have an inconsistent system of equation unless this thing is satisfied. Okay. So we know from chapter 1, or from the last lecture also. So moreover, Ax equal to B can be solved if and only if. So this is if and only if, or this is also known as if and only if B belongs. So this is belongs. B belongs to the column space of A. If it belongs to column space of A and not the column space of U. Why? Because when we are doing elementary row operations, operation change the columns. So this is not, so the linear combination of columns of U is not the linear combinations of columns of A. Not U. Why? Because linear elementary row operations imply elementary row operations imply a combination of columns of U are is not the same as combination of columns of A. So column space, we cannot find the column space from the column space of U. For the column space, we have to look at the corresponding columns with pivots in the original matrix A. So this is a you need to remember this thing, that you cannot directly write the column space of A from the matrix U. You have to go back to the original matrix and then from there write the column space of A. Okay. So what about the column space? So column space of A is the plane is the plane generated by the independent columns of A. And what are those columns? Independent columns of A implies columns that correspond to columns with pivots in U, and we already know from when we started this lecture that we said this column, the first column and the third column are independent. This is independent. So we said this is column A1, this is column A2, this is column A3, this is column A4, and we said A2 is 3 times A1, and we said A4 is actually A3 minus A4 is A3 minus A1. So these are the two independent columns. So obviously the column space is going to be generated by this one, and these are the ones that correspond to the pivots. So where is the pivot? So our pivots are this is a pivot. Pivot is the first column. So this pivot in first column, and pivot in third column. So obviously these two columns so pivot in first column corresponds to this one, and pivot in third column corresponds to this one. So the first and the third column are independent. So we say the column space of A is generated by the columns that correspond to the columns with pivots in U, or CA is generated by 1, 2, and minus 1, right? 1, 2, and minus 1, this one, and 3, 9, and 3, and 3, 9, and 3, and 3, 9, and 3, and this is the set. And just see that these are number of independent vectors equals 2, which is the number of pivots, right? Okay, good. So let's see. So let B be equal to 1, 5, 5, and we said, so recall, we said AX equal to B will have a solution if where is that, if B3, if this is true, if B3 minus 2B2 plus 5B1, if B3 minus 2B2 plus 5B1 equals 0. So this is B1, this is B2, this is B3. So B3 is 5, this is minus 2B2, which is 2 into 5, plus 5 into 1. So this is equal to 5 minus 10 plus 5, which is equal to 0, which is this. So this B lies in column space of A. Okay, so obviously we are going to have a solution. So let's find that solution. So that solution is AX equals B, and let me write it directly, and we then know or RX equals D. So, or maybe I write or UX equals C, UX equals C, or Rx equals B. So let me write this thing. So Ax equals B means 1, 3, 3, 2. 1, 3, 3, 2. 2, 6, 9, 7, minus 1, minus 3, 3, 4, U, V, W, Y equals 1, 5, 5. So this is B, this is X, this is A. Okay. And when we did the row operations, we got this is still U, V, W, Y. We got 1, 3, 3, 2 here. We got 0, 0, 0, 0 here. We got 0, 0, 3, 3 here. And this one was B1 was B1. This was 5 minus 2. This was 3. And obviously this is 0. Okay. So this is U. This is still X. And this is C. And or so we want to go solve further, or we say or 1. So now these are the pivots, and I want to make everything above and below the pivot 0. So 1, 3, this was 0, this was minus 1 if I recall correctly, and then this was 0, 0, 1, 1. This was 0, 0, 0, 0. Again U, V, W, Y. This is still X. This is A. And this is 1 is still there. And this is still 0. And this one, sorry, this is 3. This is not 1 because this is not changed. And we said, but actually this is 1. This is not 3. And we said minus. So this should be minus, I think. So it's minus 2. Okay. Now, how do I directly write the equation? If you look at this one and this one and this one, so you have, so this implies U plus 3V minus Y equals minus 2. And this one implies W plus Y, W plus Y, W plus Y equals 1. Okay. So this is my pivot variable as before. This is my pivot. This is my pivot. And this is my pivot. Okay. So these two are pivot variables. Pivot variables. And these two are my free variables. Free variables. And if you recall, when I want to write it, so I'm going to write X equals U, V, W, Y equals, this is already on the right hand side, so this is going to be exactly the same. This is my particular solution. This is my particular solution. So I'm sorry, this is not a particular solution. This is, I'm sorry, this is not A, this is R, and this is B. So this is equal to minus 2 here. So minus 2 as is, plus the free variables are V and Y. These are the free variables. So V, Y, and we know, so this is minus 2, and we alternately put the free variables 1 and 0. So 0, 0, and 1, right? So these are my free variables. So free variable, free variable, free variable, and free variable. These are free variables. Okay, maybe I write it here. These are the free variables. Okay, so -2, this is -3v. So again, if I look at this one directly and I look at this one directly, so this 3 will go here with a -1. This 3 goes here with a -1 because this is on the left of the equal to sign. This 0 goes here, and this is again negative, doesn't make a difference here. This -1 goes here. This is +1, again with a negative sign because it's on the left of the equal to sign. And this, there is a -1 over here. This -1 goes here again with a negative sign, right? Okay, what happens here? So this is -2 here, and then W is equal to 1 here. So W -2 as is here because this is on the right of the equal to sign. This is the right of the equal to sign. So this is as is, and this one will go over here as is. Okay, and V is a free variable, Y is a free variable. So free variables here are 0. So free variables here are 0. So these are free variables, and these are free variables. These are free variables here. So how do you write the solution? So this, by the way, is XP, the particular solution. This, by the way, is XN, which is the null space solution. So XP may your free variables are set to 0. XN may your free variables are alternately set to 1 and 0. Free variables are alternately set to 1 or 0. Okay, so actually all free variables are set to 0. So if there are R pivots, so let's stop here. Just let me recap. If there are R pivots, this implies R pivot variables, and N minus R free variables. So it's the number of free variables that generates infinitely many solutions. That's why AX is equal to 0 has infinitely many solutions. So if there are R pivots, this implies R pivots variables and N minus R free variables, where R is called the rank of the matrix. The rank of the matrix and obviously, which implies rank is less than equal to minimum of M comma N. So it's either less than the number of, depending on whether M is larger or N is larger. So it's a minimum of both M and N, and that is called the rank of the matrix. So let's stop here. So next time we are going to do an example, and then we are going to move on to independence, basis, and dimensions, and touch on the remaining two, or probably discuss, or maybe we are going to touch on the remaining two subspaces, which are the row space and the left null space. If you have any questions, you can again email me, or we can discuss it on Mondays and Wednesdays. Thank you.